Oh, God damn it, why did I make it so heavy? Right. Oh, yeah. Oh. For the last couple of months, I've on and off been putting this thing together, and if I had to describe to you what it is in a sentence, it's a green thing that's a delay that's a thing that spins. But this is the next project in my tape experiments. I've already done a few things. In fact, I've made a playlist which didn't exist before because it wasn't really a thing until I realised I kept on plonking together tape things. I've got a big old list of experiments and machines I want to try and build with tape. However, I am bound by the physical world and reality, so it's going to be a bit by bit affair. Whilst words and ideas sound fantastic, it's always a pain in the derriere to actually turn words and ideas into functioning things that also function 99% of the time, every time. With that in mind, I want to show you the latest in this kind of experimental series, which is basically my take on something like a Binson Echo Rec, but it's not really like a Binson Echo Rec. The first thing you'll notice is it is a big metal box section cube.
That's right, the first thing we needed to do was build a suitable enclosure, and since I had the Rapidor Manchester by my side and some spare 2x2 box section, it made sense to build it in a skeletal form and go from there. So this is all the parts we need, and we're just going to weld them together like this on a flat bench. I've used these kind of 90-degree clamps. I know this is an Amazon link, but look at the price of that. An exceptionally cheap method of making sure it's square. Lovely.
And since I have a snazzy tin of Hammerite green, well, yeah, obviously it's painted Hammerite green as well. Looking on the top of the machine, ignoring the dust because, yeah, it's been a very on and off project, you'll see a big chunky bit of disc on the top. Yes, instead of the machines like the Binson Echo Rec and things like that, where it's actually recording wire that's wrapped around a disc, and then the radius of the wire is actually flattened down on the corner to make a better surface to record onto. I went for a bit of a different approach because I'm curious on the actual ruggedness of this, but you'll see it's actually inch-thick tape wrapped around an inch-thick plexiglass disc. Why? Why not? But the radius is a lot larger than a Binson. The idea is it's not just a delay, it's also a loop generator, and in theory you can fit more tape heads around it. Anyway, first let's have a look at how we got to this point.
So I used a nice shiny piece of acrylic plastic so everybody could see what's going on the inside. However, this has a downside. Yes, it's exceptionally flexible, and when you have stepper motors dangling off the middle of it, well, it's gonna be sagging, so we've got to put a little bit of a central kind of stabilizer in there. This doubles up as an adjustable piece, so we can use that sag actually to our advantage to be able to make sure the whole disc runs flatly with this slight fine-tuner thingamajiggy in the middle. The first circuit board we're going to be putting in is the stepper motor driver. This is exactly the same circuit as in the stepper motor Leslie and also the pitch shifting tape machine. Anyway, I ordered this snazzy bit of inch-thick acrylic plastic that was in a circular shape, and it also had a hole cutting in the middle, thinking that that hole would be cut exactly central, but it turns out it wasn't. So this is my milling machine. I got a Facebook Marketplace. Oh, it's amazing what you can get for a couple of £100 if you're looking around, but I couldn't really balance it, so I decided to put it actually onto the machine and spend a couple of hours, well, that's a lie, nearly an afternoon balancing it. I found this was the best method. It was using a Stanley blade and a good few hours of just tapping it every so often, just giving it a tap so it got closer and closer to the disc until that sound was a completely smooth shh, which meant it was perfectly balanced. The more balanced I got it, the more balanced the sound I got out of it would be. Anyway, after getting the air compressor and harmonizing with it, come on, everybody does that surely. We just wrap a bit of inch-thick tape around it and hope for the best. This bit in the middle was a very early design. It was literally a clamp that held the Allen key that went into the grub screw on the top of the stepper motor. A temporary solution for a temporary time in the machine's life. Anyway, look how smooth this is after you've got it all tuned up. Lovely.
So with only one tape head, we've got a reed head, we've got a record head, and if you put the record head onto it, you'll hear what we're about to record onto the tape. In fact, I think there is some already on it because I didn't actually erase it. Right, so yeah, let's erase it first. Oh. Right, so Now we can make a bird synth, so we're using it statically. The great thing is with these 3D printed things that I made, is no matter, you're always going to be in line. So this is exactly the same tape head as this one. We're using all of the tracks of the tape head to actually play on, so it's actually recording a nice chunky bit of magnetic data onto the tape. So it's going to be, the tolerance is quite good, but we're also going to be the same height, so we can write onto it little birdie sounds. Go back. Go forwards to it. Oh yeah. Slow it down a bit. Speed up a bit. And it's gone. So there's a cool unintended outcome of this.
The next thing I did was use this old reel of 3D printed filament to be able to mark out evenly 16 lines that would be designated to tape heads, because it had 16 lines on it, amazingly enough. And after a bit of tompokery, I placed a few of the tape heads in place. The idea of them being equidistant around the loop is that you can make rhythms and make a rhythmical sequence if you so please. Let's find out how that goes. That is just a playhead and a reed head. Now we're going to add a few more reed heads equidistantly around the circuit to be able to delay the sound as it spins around. It gets read multiple times by tape playheads or reed heads. We're going to use the Furby to demonstrate how this sounds. Going to add an erase head. You'll notice it's on a very thin mount compared to the others, so it can fit between the record head and the last play head, so you don't miss any of the kind of resolution, really. This is me fine-tuning the height of the erase head. With tape, the tolerance is kind of loose, so you can just adjust a ill-fitting erase head, which is what I'm doing here with a screwdriver, to make sure it erases sufficiently in the magnetic track.
On this side, there's a piece of plexiglass with a bunch of circuit boards on them. These are actually pretty much exactly the same circuits as in the copycat. It's based around a single TLO72 op amp that amplifies and filters the signal coming from the tape reed head. It is largely based on Music Thing Modular's Magnetophon, which is a Eurorack format tape head amplifier. So you plug in an external tape head into it and wiggle it around on tape and it amplifies it to Eurorack level. But as you could tell earlier in the video, you could just plonk a tape reed head onto a jack socket and literally use it with a guitar amplifier, as a tape reed head is basically the same thing as a guitar pickup. So this is on another piece of plexiglass, obviously cut all of the holes and then plonked it onto the enclosure, and then put all of them on the inside, connected a ribbon cable that basically connects all of them together. The top knob is for gain, and then the next ones are literally just volumes for the outputs. You'll notice that there are 5 separate outputs for each of the tape heads. That means you can adjust the intensity of the feedback coming out of the separate tape heads going back into the input of itself to make it go blah 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 blah. I'll demonstrate it when we actually get it working. working because it isn't actually wired in yet. The next 4 are separate outputs. That's right. Remember in the copycat video, there was 2 separate outputs. That means you could send the separate tape head to either the left speaker or the right speaker in a stereo field, meaning it became a stereo tape delay even though the input was a single mono signal. So each of these have a separate tape read head from around the drum going into them. Then you adjust the separate gains and turn up or down how much of that single tape read head goes into the separate outputs. As you can see, each of them are connected via this ribbon cable, which is actually the power. We're connecting a ribbon cable below, which actually connects all of the outputs together. Then that ribbon cable travels over to this circuit board, which has 5 mixer circuits. So the feedback output goes to one of the mixer circuits, then the other 4 go to the other 4 mixer circuits. These help mix all of the signals together and then send them out of a separate one of the 4 outputs each. Oh, and not to mention, an upgrade from the last copycat is a separate jack output for each of the tape read heads, meaning if you really wanted to, you could plug a separate speaker into each of them and then put them around your head or something. The best way of showing you if you don't understand is finishing the machine and seeing what it does. So let's start by putting this circuit board into the machine.
So we're going to plop that in there and then wire in the 4 outputs into that circuit board. Why 4 outputs? Well, it means that you can adjust it and send it out of, like, if you want 4 different types of speakers, so it could bounce around your head, or it could be 4 different effects pedals if you really wanted to. Anyway, we're only going to experiment with only one of the outputs first, just while we're putting it together. You can see later on in the video, there is a demonstration of using all 4 of them doing some funky monkey stuff. If you listen closely, there is a bit of warbling. That's because the stepper motor that is directly driving this disc is sort of struggling. The more tape heads you add, the more torque. In fact, here is a situation where it is stalling. We need to solve this problem.
One of the downsides of using a stepper motor directly driving this is the more you add the tape heads, the more torque is required to drive them. I always knew this was going to be the problem, and the plan was just to get bigger and bigger stepper motors. However, after speaking to my friend Dave Nervous Squirrel, well, he let me know about this thing. What is this, you ask? Well, this is pretty damn cool, that's what it is. It is a gearbox that takes up the same footprint as the stepper motor it is made to be a gearbox for. The stepper motor I'm using in this is a NEMA 23, it's quite a tall one as well, and yeah, this takes up the same footprint but it actually sits on the front of it, so it makes it longer at the back, but it's actually the same height. It's got a thicker shaft at the end of it as well. You can get these in various gear ratios. I think I've gone 5:1 because for us, speed isn't the most important thing. It's smoothness, accuracy and torque. So we now need to figure out how to plonk this in here.
So let's take it all apart again. Finally, we can remove that dodgy Allen key bodge thingamajiggy, but we need to remove the central stabilizer as well because that needs to be a different size. So we need to make a new one of those. So that's going as well. And then we can take out the stepper motor because the shaft of this new gearbox was a different size to what we originally used. We need to make a coupler that is 14mm on the inside and 18mm on the outside, so it fits nicely inside the disc. We're going to add some holes to put some grub screws and tap it to fix it in place, and then also mill a bit from the fantastic Facebook Marketplace milling machine. It was very cheap to make some engagement pieces for the disc to be able to bite onto. Now we put the gearbox on top of the stepper motor. It's very simple, 4 bolts around the side and then 1 bolt inside that hole to be able to clamp the shaft to the gearbox and then give it a test. Lovely. Now bolt that in place with a new central stabilizer underneath, kind of get that up to the right size. Now we need to 3D print something to be able to connect the motor to the disc, so I'm going to be using this thing called a top hat, an engagement top hat. It's got a couple of dogs on the inside that actually clamp into that collar, and then we're going to 3D print that and then bolt it on top of the disc, so those 2 little grooves that are sticking out, they're going to be able to stick onto that. In fact, I ended up going for 4 grooves around it. So this is the actual collar, and then there's the 4 grooves because it is just plastic after all. Want to give it the best chance it can get. And yeah, it's running much better now. Look how lovely that is, even with just 4 tape heads.
think we can afford to get the stepper motor going even slower on the Arduino code to drive the stepper motor, which is even cooler because we can make it go really slowly. The next thing we're going to do is put more tape heads onto it. I realise I haven't spoken about the tape reading mechanism. Well, from the other tape experiments, it's proved vital that you have a bit of tension against the tape. In the copycat, you'll see there is a bow. That means there is an equal amount of pressure over all of the tape heads in that bow. Well, I just plonked together the first thing that came to mind on the 3D printer, and it is this shape. It basically goes backwards and forwards. And also behind the tape on the drum, there is a bit of a padded layer to aid with the magnetic adhesion. Anyway, let's pop 4 more of these tape heads in it, and then we'll have 9. The reason 9 is we've got 8 of them equidistant around the drum, and then we've got just 1 more right at the end, just before the array's head, so we get the last little bit of it before it all gets deleted. I've laid it on its side now, which has meant the tracking's a little bit out. I might actually swap the front panel for something a little more rigid so all of the tracking stays the same, but it doesn't matter. This is experimental time. It's not a finished thing. I've got all 4 outputs wired in. So if I turn on the first one, it's coming out that side. Turn on this one, it's coming out that side. Turn on the next one, it's going to a pitch shifter. And turn on the next one, it's going to another pitch shifter. So the first tape head we're going to do, next tape head we'll do this, and the next tape head we'll do, and then the next one we'll do. And then we'll bring them all in later on as well. I'm going to save on the variety of the sound examples until I get it a little bit further along. I think I'm going to replace the front panel, make it more sturdy, add more tape heads, and also add the knobs below it. So instead of this cube thing, which I've gone off, I think I'm going to add another cube underneath, get all the knobs underneath it, and then after that, in another part, also build this into an amalgamation of the real-time tape pitch shifter. Don't know how it's going to work exactly. I've got a few ideas in my head, but watch this space. There's going to be plenty of things I'm going to do to this. The video won't be next week. It might take a little while. It might take a month or two, but I'll be doing all of the updates as I've been doing on this one for the last 2 months or so over on Patreon, including loads of audio examples that are much longer. So if you're interested, you can download some of it also as sample stems. They're available over there as well. So if you're curious how this project and many, many more are getting on, then go and check it out over there, because needless to say, it supports all of this. And ultimately the museum, this museum's not obsolete, but this will end up going in for people to be able to use. I was hoping to have this done a little bit more to have it sort of safe and playable in the museum, but it's not quite there yet. So I'm going to keep on cracking on in it. And yeah, I'm no computer. This is the spinny delay thing of doom thing. And if you like, we'll see if I can subscribe and don't be scared to try it. Toodaloo.